Our paper is Systematic Assessment of Fuzzers using Mutation Analysis. And yeah, my name is Philipp Görz. Let's get started. So fuzz testing, fuzzing, well, we just heard like 5 talks about that. So I don't want to go into detail. But what we are concerned with is evaluating fuzzers. So, and I want to motivate mutation analysis by taking a look at a few approaches that you can use for evaluating fuzzers. And I want to look at 4 criteria, but it should be comparable. The bugs that you analyze should be unbiased. So that means even bugs that we would not yet expect to know. So for example, before heartbleed, we did not know how to detect this. And mutation analysis, by being unbiased, a evaluation benchmark allows us to even model these bugs that are not yet known. Also, it would be great if you can use custom subjects. So if you have a fuzzer for TLS libraries, you can just use TLS libraries to evaluate your fuzzer. And it would also be great if you have like a complete list of faults that you can use and that you can check off. All right. So one approach is coverage. It's like you have your line and branch coverage, and this is a fine approach. It is comparable, and you can use custom subjects. However, you do not learn how well your fuzzer evaluates bugs or finds bugs. And yeah, so you need to cover a line, but you need to cover a line to find a bug, but it's not enough to know if a bug would be found. So how about we evaluate fuzzers on finding new bugs? So you take your fuzzer and you find new bugs. Is that a good way to compare fuzzers? And the problem is that it's not really useful to compare 2 different bugs because you do not, for example, you have 2 bugs in the Linux kernel. Which one is worth more, or how do they compare to each other? So you can't really compare fuzzers using new bugs. Also, it's not an unbiased approach because the bugs that you will find in the wild need to go through internal testing and then also be found in the wild. So this introduces bias. Yeah, you can use custom subjects, but we obviously do not have a complete list of new bugs. So what about we just take these bugs that we know of and we try to refine them? So this is, for example, what Magma is known for. It's a bug benchmark for fuzzing. What they do is take a bug report, take a look at what the fix was for this bug, and then they create a patch that reverts this fix, so that they can then inject this bug into a current version of the subject. So how does this compare, or how does this fulfill our criteria? Well, now it's comparable. Obviously, we have a list of bugs. However, it's also not unbiased because the bugs that will be added have the same problem or the same bias as new bugs, but additionally, they need to have been selected to be included into the Magma framework or the evaluation. Also, you do not have custom subjects. You need to use the subjects that are, for example, in Magma. I think they also guarantee that the bug they inject can be triggered, so this is good. So how about mutation testing, mutation analysis? And the tagline would be fuzzing your test suite. It's the golden standard for evaluating your test suite and mostly known in software engineering. So how does that work? So for example, you have some code and mutation analysis would introduce mutants. So for example, you have an unsigned integer and it would be changed to a signed integer. or you have a comparison and would be changed into another comparison. Or you have like an offset that you would add somewhere. And the thing is, you would do this everywhere it's possible. So you introduce these mutations exhaustively, and this allows us to reduce the bias. So to evaluate your test suite or your test generator, or fuzzer, let's start for example, with a test suite. You have some code, and initially the test suite passes. Then you introduce one mutation. For example, you change the comparison, and now either your test suite fails, which means your test suite detects this logic was changed, and it has killed the mutant. However, if it does not fail now, well, your test suite is maybe not thorough enough, and you might need to improve. And this is the same mechanism that we use to evaluate fuzzers. So how does this compare on our criteria? Mutation testing, well, it's comparable. You can see if a mutation is killed or not. It's the least biased way because of this exhaustive application for each mutant. And, well, you can use custom subjects. However, the problem is that, you give up that you have a list of complete false. And we think this is worth it because you will get this unbiased way of evaluating fuzzers. So what was the problem, or what's the problem with using mutation analysis for fuzzer evaluation? Well, the problem is it's very computationally expensive. Mutation testing requires that you execute a test generator or test suite for each mutation. And fuzzing, well, the more executions, the better. So what did we do? Our contributions are obviously that we need to reduce computational costs, as it would be infeasible otherwise. We do that using two approaches. One is split phases, and here we split that into an initial coverage fuzzing phase where we maximize the coverage. So we give fuzzer some time to gather an exhaustive set of seed corpus, and then we use it on the actual mutant binaries to see if they find or kill the mutants. So splitting this up greatly reduces computational costs. Also, we reuse the concept of super mutants, and this allows us to evaluate multiple mutations in one run. So you would have several changes. However, they are we ensure that they are independent of each other, which allows us to have them in the same binary. Then we also provide a set of mutations operators. Those are traditional operators and, well, security-specific operators. And, well, you can find the full list in the paper. So what are our results? Well, we see that coverage accounts for most of the mutants that are detected. And this is actually, we can see that the results are pretty much similar to what you get from FuzzBench. However, what we can also do is evaluate for oracles. And for example, if you add address sanitizer, you will see an increased number of killed mutants. And, well, you can now, using this method, evaluate how well your sanitizers work. And, well, what we found is that it seems like fuzzers have reached, or at least the fuzzers we looked at, have reached like diminishing returns. And it seems to us that improving on oracles or sanitizers is actually much more fruitful. And well, we did a study that the mutations we used are actually similar to the CVEs, and yeah, to resemble CVEs and yeah, create real faults. So you can find the code here. Yeah, if you are interested in using this method, we are happy to talk to you, and we maybe use this for SBFT 24. Yeah, thank you for your attention.